Hello and welcome to this video lecture for Chapter 5, Schedule Planning. So let's get started. The agenda consists of three things. First, the question, what are the activities of the project? Second, when will the activities be performed? And third, an introduction to a concept known as critical path analysis. Just a quick reminder of the project life cycle. We are in the planning phase and we are now we've completed scope planning and we're now moving on to schedule planning. So let's take a look at where we are. Now again, for the two questions, what are the activities of the project? The result is the creation of what is called an activity list. And then for the question, when will the activities be performed? The result is the creation of the project schedule. So those are our two outputs from this. So first question, what are the activities of the project? Recall that during scope planning, the project was broken down into a number of deliverables and ultimately down to work packages, each representing a part of the project to be delivered. The deliverables are broken down into smaller and smaller deliverables. The smallest are called work packages. So that's a review of Chapter 4. During schedule planning, though, for each work package, the activities needed to create the work package are defined. So it's not enough to define what it is we need to produce. We're now taking it further and saying, what are the activities? What things do we need to do in order to create the work package? So that's our next step. Now, sometimes there's a confusion of, well, how many activities should be defined? When defining activities, that's the question. This is the question. For example, for the work package final report, let's say that we have a project where we're creating a final report. Should there be a smaller number of activities defined? Like, for example, here, create draft copy, create final copy. Or should we have a larger number? Should we have, in this case, 5, perform research, create draft copy, perform edits, proofread, create? So which should we do? Should we do 2? Should we do 5? Should we do 10? Should we do 1? How do we know? What are the important factors to be considered? Well, this is something that needs to be considered, and there are a number of things that should go into thinking about this as to uh, as to how to determine this. And if you refer to your textbook, for example, on page 49, you can see there's a number of factors. Each activity, you'll know when to stop creating activities when each activity is clear to those who will perform the work. Um, when the duration, the amount of time the activity should take, is a moderate amount. You shouldn't have extremely long durations of time, like an activity taking 30 days. You also shouldn't have an extremely short duration, like something that's going to take 2 minutes to do. That's too short. So there's sort of a moderate um, duration, usually in the few hours, half day, a day, sort of duration is usually normal. And each activity should have an identifiable person or group who will be responsible for its completion. If you find yourself having an activity where somebody does the first half of it and then somebody else does the second half of it, it's probably two activities. You should have, a single person or group performing the work on a given activity. So there's various factors that go into it. At this point, please pause this video, refer to your textbook, and read the case study update, creating the activity list. So do that and then come on back here. Okay, so we're back. Sophie, the project manager, takes a low-tech approach to creating the activity list. Sometimes low-tech solution using sticky notes or pieces of paper can be quite effective, which you'll see in this textbook. She writes down each work package from the previously created work breakdown structure on a piece of paper. So this is very important. When you're creating activities, which leads to the schedule, it's the work breakdown structure that drives it. You're not creating it like anew. You are using what you previously created as the starting point. So the work breakdown structure is very important. For each piece of paper, that is, each work package, she then thinks of the activities needed to produce the work package. She writes these on the paper. So she's going through this process. This approach helps her to focus on each work package individually. So she can just take one sheet of paper at a time and then think through, okay, for this one work package, what one or more activities do I need to do, or the project needs to do, in order to create it? And this is quite a useful exercise. So this results in the following. We have the following 9 pieces of paper, which represent each work package. Now, notice that there's 8 that were there from the work breakdown structure. We've also added a project management work package, because that's another thing that is done and oftentimes doesn't appear on the work breakdown structure, but should. So, or should be considered work that is done. So here we see for the trade show signage, she defined 2 activities: create sign graphics / text and order banner stands. For the promotional video, which is down on the bottom row, there were 4 things: develop video concept, develop video storyboard, develop video script, and create video. Now, again, why there are 2 or 4, or potentially there could be 6 or 10, it depends on those things that I talked about on a previous slide in terms of the all of those different criteria. But here's what Sophie came up with in terms of her activities, and this is the activity list. So this is the activity list, or the list of activities to be done. Now the next question is, when will the activities be performed? So once the activities of the project have been defined in the activity list, the timings of each activity needs to be determined, because you'll have noticed on that previous slide, there was nothing in the activity list that said, well, when will they be done? Which will be done first, second, third? On what dates should they be done? The activity list is silent about that, so we need to go further. So when determining the timing activities, we need to think about, and it's based on either the required sequence of the work involved, and there's oftentimes sequence when you do work, that you have to do this before you can do that. That's called a dependency, that you need to, first prepare, then perform, as an example. That's an example of a dependency. The other thing that can affect the timing activity is that if it needs to occur on a certain date, a meeting that's being scheduled is scheduled for a date when everybody is available. So that's where a required date comes into play. At this point in time, please again pause the video, go to the textbook, and read Determining When the Activities Will Be Performed in the current chapter. So once you've done that, come on back here. Okay, so let's take a look. Sophie realizes the activity list is not in any particular order, which is true. So she writes the names of each activity on a sticky note and places them on her office whiteboard. This then will appear as follows. So this is what she did, is she wrote all them down, each of the activities that was on our activity list, and there it is. It's just in kind of random sequence. So now she needs to go on from here, because this isn't useful. But what is useful is to put them in order, and that's what that will create is something called a network diagram. A network diagram is a useful tool for displaying the logical order of activities. So it can be quite representative of a schedule. Each activity is represented by a rectangle. An arrow between the two rectangles represent dependencies between them. So an arrow will represent the dependency between 2 activities. For example, if activity A should occur before activity B, it would be represented as follows in the network diagram. For example, here's where we have activity A, which is a rectangle. Activity B, that arrow indicates that A should occur before B. And that's the basic building block. of a network diagram. Now, this is the result of Sophie spent a lot of time. She thought about each activity and she put them in order, and she rearranged them and so on. She put the arrows between them, and here's the result. And you can see it starts on the left side. So it starts over here with initiate the project, then plan the project. And then we see there are three paths that occur. The first one starts with create sign, graphics, text, and then we order the banner stands and so on. So each of these activities occur in sequence. Then, at the same time as this one, this create social media strategy can start, and we can see all those dependencies. And then at the same time as those two, this develop video concept can occur. So then we see there are four activities that are running parallel to these, which run parallel to these. Now, once all three of those are done, so once we've ordered the mural and tripods, once we've sent the press release, and once we've created the video, we can then close the project. So that is a network diagram. It shows us the order of the activities. Now, another thing we need to do in order to create a schedule is estimate, well, how long is each activity going to take to complete? What is its duration? The duration is the total elapsed time that we are going to allow or plan for the activity. Now, there's a question. What is the difference between the duration of an activity and the work involved for an activity? Are they the same? So that's something, take a look in the textbook and see what you think about that. They are different concepts. The duration is the total elapsed time. However, the work involved depends on the individuals who are team members, individuals that are assigned to the activity and how much they're working. For example, if you had a 2-day activity where someone is working for half time, for half of their time, 50% of their time, well, then the duration would be 2 days. The work involved would be 1 day. If on the same 2-day activity you had 2 people working on it for full time, then it would be a 2-day activity and 4 days of work. So you see how they are different concepts. They have different purposes, but they both are important. They're both different. Now, how may the duration of an activity be estimated? This is always a tough question as well. How do I know how long something's going to take? Well, again, check your textbook, but there's various things. It's the complexity of the work, the amount of work. The other thing is the experience level of the person who is assigned. Somebody that's very experienced and knowledgeable will be able to do something faster than someone who is inexperienced and is learning how to do it. So there's many factors that go into estimating the duration of an activity. So here's the activity with durations assigned. You can see, for example, initiate the project has a 3-day duration. Order the banner stands has a 1-day duration. No, bear in mind, that's not the amount of work. That's the duration. That order the banner stands, the amount of work might be 10 minutes, but it will happen within a 1-day time period. So that's the difference. Again, remember the difference between duration and work. That now brings us to the project schedule. There are many different ways and many different types of project schedules that may be used. In effect, there is no one way to create a schedule. The amount of detail and complexity required in a schedule depends on the characteristics of the project. So you can have very simple schedules for simple projects. You can have very complex schedules for complex projects. So the one size fits all model is not useful. There's 3 main types that are discussed in this chapter that we're going to look at. One is a milestone-based schedule. Another is an activity-based schedule. And finally, there's a dependency-based schedule. Milestone-based schedules are fairly simple. They are based and include only the major milestones. So here we see the schedule for the DecoCam project, we can see there are 5 milestones with 5 dates associated. Now, the advantage is it's very simple, very easy to update, very easy to understand. The problem is there's not a lot of detail here. For complex, large projects, this can be a little dangerous and should only, usually be used on very simple or small projects, or as maybe a summary of the more detailed schedule to give to senior management and other stakeholders. The activity-based schedule, and this is only part of it, is like a milestone-based schedule, except it is showing the detailed activities that have been defined. So generally, you can see it's in the form of a table, often produced in Word or Excel or different products like that. And we can see that we have durations, start dates, and end dates. So a lot more detail. Now, the advantage of this type of schedule is still relatively simple to create. It's using tools such as Excel or Word. It's easily accessible, but it's more work than a milestone schedule for sure. And one of its downsides is that you can't see the dependencies between activities. It's not apparent in this schedule as to, well, is there any implied order that occurs here? It's just showing the dates they should start and end. So it's not showing dependency information. There's another sort of specialized type of tool. This is something that you will see in more detail when we in chapter 17 of the textbooks, which refers to Agile, and this is a workflow approach schedule, which splits our activities. It orders the activities into to-do things that are needed to be worked on, things that we are working on, and things that we are done. So this is a simpler type of monitoring activities, and is generally used in Agile techniques. So we'll have more information on that in a later chapter. And finally, there's a dependency-based schedule, otherwise referred to and often referred to as a Gantt chart. And this is where it has the characteristics of the activity-based schedule, but also the activity-based schedule, which you can see each activity and the durations, but it also has this calendar idea on the right side where we see each time period showed as a column, and then we see the duration of each activity shown as a bar going across the timeline. Dependencies between activities are also shown. So we can see there's a dependency between these activities. We see there's a dependency between these activities, and so on. Milestones are usually shown as diamonds and have a 0-day duration. So it also displays the milestones from the milestones. So this is the ultimate. Dependency-based schedules are the ultimate in terms of detail. And that's one of their advantages, is that they are very detailed. They are very useful for complex projects where maintaining dependencies and understanding them are very key. So that's sort of the upside. The downside is they're very complex. They often require the use of specialized software, such as MS Project or other packages, and are a little more difficult to use. So they make more sense on projects where you really need this level of detail. More about dependencies. So just we've talked about dependencies a fair bit. There are finish to start dependencies. Those are the ones that we have seen so far. So all of the dependencies in the network diagram are finished to start. That is, the first task finishes, then the next one starts. That's called finish to start. There are dependencies which are referred to as start to start. So this is where we have two activities that both are required to start at the same time. So in this case, perhaps create outreach list and perform outreach are designed to start together, but then because they have different durations, they may finish at different times. Finish to finish dependencies, on the other hand, are sort of the opposite. They're designed to finish together, right? So we have two activities that, because of their durations may start at different times, but are designed to finish together at the same time. So that's a finish-to-finish dependency. There's the concept of dependency leads and lags. A lead is you can think of as an overlap, where in this case, a lead of 2 days means that for this dependency, this second one can start when this is within 2 days of finishing. So you can have a finish to start dependency with a 2-day lead, means that the second one starts 2 days earlier. So it doesn't have to wait for this to finish, but can start when this is within 2 days. A lag is kind of the opposite, is that it's a gap between two activities. So this would be a finish to start dependency with a 1-day lag, where 1 day, instead of this activity occurring right after this one, it waits a day and then starts. And there can be various reasons why that would be required. Okay, now we're going to move on to a high-level overview of the concept of critical path. The critical path is defined. It's an important concept for managing projects, and a critical path is defined as the longest sequence of activities in a project schedule. And this longest sequence represents the earliest planned completion time for the project. So let's look at an example. For the following network diagram, what is the longest sequence of activities or paths? So let's just look at this for a moment. This is an example of preparing for a vacation. And we can see that it's a network diagram. We can see that we have to select our destination. And then while we're applying for the passport, which has a duration of 10 days, we can book the vacation 1 day, pack for the vacation 1 day. And then when they're finished those two, we can depart. Okay, so we have 5 activities. Now, how many paths do we have? Well, if we look at this, we have 2. There's one path, and there's the other path going through that way, which means there are 2 paths. And if we add up the duration of each, this first one has 12, 13 days. The second one has 1, 2, 3, 4, 5 days. So the longest series of activities is this one that goes along the top. Select vacation, apply, depart. It is therefore the critical path. And it defines the earliest planned completion date, which is 13 days. So it's useful on projects. Now, this is a fairly simple network diagram and project. We probably could have seen that, that would have been kind of apparent anyways. But on larger projects, this becomes more important. Now, there's another concept which is known as calculating float. Total float is the amount of time an activity may be delayed before it delays the project end date. So that's the concept which is known as total float. So now the question is, how much total float is contained in each of the activities below? So that's something for us to consider. Now, one of the things when you're solving this type of problem, and again, I really recommend you to read this section carefully in the textbook. The critical path, by nature, by its very characteristics, all have 0 total float in each activity. So, for example, this has 0 days, this has 0 days, and this has 0 days. The reason being is because it's the critical path. If you delay any of them by any amount of time, it'll delay the entire project. If select vacation takes 3 days, this will become 3 plus 10 is 13, 14 days. So we've delayed by a day. So all 3 of these have 0. Now the question becomes, well, what about these 2? They're not on the critical path. And the way you look at this is say, okay, while these 2 are occurring, this 10 days is occurring. You can kind of see that in the network diagram, is that these 2 occur while this one takes place, the critical path activity. So while these 2 days are occurring, 10 days are occurring. So the amount of total float that each activity contains is 8 days. 10 days minus 2 days, which equals 8 days of total float are contained in these two activities. And really what that means is that either one could be delayed by 8 days. Or you could delay the book vacation by 4 days and pack vacation by 4 days and have no effect on the project. If you delayed those two activities collectively by 9 days, then you would delay the project. So that's what the concept of total float is. Now here's a more difficult question: is what is the critical path for the case study project? And this is a trickier one. I really recommend you to check your textbook. It's on pages 64, 65. But if you do that, if you go through the math and realize, well, there's really 3 paths through this network. There's one that goes here, okay, down to there. There's one that goes here in the middle and then down to there. And then there's a third one that goes across here. Well, the critical path, if you do the math, is the bottom one. It's initiate project, plan the project, and then the video activities. It has the most it has the most duration, the highest amount of duration. And if you view that, it'll show you that is the critical path. Now, the next is to calculate the total float for each activity. And again, that becomes tricky. Now, the total float in the critical path, again, is 0 days. So this initiate the project will have 0, this will have 0, develop video, the storyboard, the script, the creation of the video, and the close the project will all have 0 total float because they are the critical path. However, now the question becomes, well, what about these other paths? How much is in there? And again, I recommend you for this level of detail to go to your textbook. But if you add up, if you notice that these all are running simultaneously, so if you add up the duration here, the 15 days, 5 days, so that's 25 days in this little subsection here. And if you subtract the days here, okay, so all that will add up to 14 days, the duration of those. So if you take the 25 minus 14, you'll realize that there are 11 days of float in those activities along this top row. Similarly, if you add up the total amount of days that are in the next one, for example, the create social media strategy all the way to the send press release, you'll see that is 18 days, which tells you that there are 7 days of total float here. And that's really what you're doing in critical path and total float. Now, the question becomes, well, why do we need this? Why would we need to calculate the critical path? Well, it does a couple of things. One is it tells you how long is this project going to take. And so it allows you to be able to communicate that to your project sponsor and other stakeholders. By calculating the critical path, you can determine the earliest planned completion date, and that's usually very important. The other thing that you can do is that you can determine priorities in terms of, well, which tasks need to start first. Sometimes you can't start them all. You can't keep them all working as soon as possible. Sometimes decisions must be made. By knowing that develop video concept, notice these 3 all start together, or they can start together. They can all start as soon as we're done planning. Well, if you had to pick one, which would it be? Now, without information about the critical path, you might choose this one. You might choose the one that you're most interested in. Well, the critical path tells you that you need to keep develop video concept. You have 0 float, total float in it, so it cannot be delayed. Versus we know that create sign graphics / text, it can be delayed by up to 11 days. Well, collectively with all the ones behind it. And this one, we can delay this row by up to 7 days. So it allows you to make those sort of trade-offs and not sacrifice the end date of the project. And that's a very important thing. So again, I recommend to take a look. Please read this part carefully in the textbooks because it is a little bit more complex, and I encourage you to review that carefully. Those are the references, and that's the end of the video lecture. Thanks, and we'll see you again next time.